Palo Alto studio connecting Silicon Valley and Wall Street.
I'm John Furrier, the co-host here with Dave Vellante, my co-host.
Welcome back to theCUBE's live stream here in Paris, France. I'm John Furrier, host of theCUBE. This is part of the Reger Summit 2-day conference, but this is day 0, Machina. This is the focus of physical AI and robotics. The market opportunity is growing significantly. It's horizontally scaling on many use cases as the technology is developing from the AI infrastructure up into machines. The physical world is impacted. David Reger is here, founder and CEO of Neura Robotics. I was just watching you on the Bloomberg set over there. Welcome back to theCUBE. Thanks for coming on.
Thanks so much for having me here on theCUBE.
So,
excited.
Robotics is that industry where you go back a decade or so ago, it's kind of like AI people. When the technology just came to the market, those years of grinding and science and research finally makes it to a market capability. And in the past 3 years, it's been really explosive. I have to ask you, what's been, in your mind, the biggest change in the past 18 months in physical AI?
I think the biggest change is actually that it's actually the mindset of people and believing in it. I think, let's say in 2019 when I started this company, I think we would probably sit here for 4 hours just talking about AI and if this is real and this gets one day real. And I think since ChatGPT, this thing changed. So everyone understands it's real, and now let's think about how to get it better, how to get it physical, how to enable it actually for the physical world, and this makes it right now explosive.
Talk about the ChatGPT moment for a minute. For robotics, ChatGPT moment was easy. Oh my God, it's so much different and better than typing on Google or researching. Things just happen, multi-step reasoning kicked in. That moment was clear. Is there a ChatGPT moment for robotics? What's your take on that? Because there's a little bit of that going on, but it seems to be slower, but is there a moment saying, wow, that's the moment, or is it just never going to happen?
No, it will. It will happen. It will actually also happen, let's say in the next, 1 year about. So right now we are getting the first hellos back and hey, how are you? So, but we are seeing right now it's really accelerating and especially the way how we see and how we do it. So what I'm talking about is actually, until now, I think the difference from ChatGPT and physical AI and robotics is that in ChatGPT you had a lot of data everywhere existing and you just had to somehow acquire them or get them somehow, and in the end, and you trained on it. While physical AI data is not existing, so it means actually real embodiment AI, data from the right sensors to the right compute to the right brain. This was not existing, and this is right now happening. So, and this is why, and I think here, the way to think that we as a company can solve all the problems of the world, get somehow the know-how to our company, this will never scale. This is but if we actually start thinking the way in platform, hey, here is the tools, here's the platform, train yourself, I think this can accelerate fast, and that's what we are doing right now.
I like that idea because, great example, LLM stands for large language model.
Yes.
That was text, that's the internet. Yeah, throw some graphics, images in there and some pictures and videos. Okay, multimodal, okay, put that there. Get it together, get some vector, get some AI on there, great. Robotics is dealing with completely different data. Sometimes it's new data that never seen before. Sensor data, you can't really go to crawl that. So this is a whole nother data problem, but similar thinking, okay, let's get the models. So it seems to be more complex, but that's what you're basically saying. It was easier for them to do it with pre-existing language, but there's no common language for robotics. You got vision, you got hardware, you got sensors, tactile.
Yeah. That's exactly the point, the reason for that, why robotics didn't take off yet, and didn't have this ChatGPT moment yet, was actually that there was not the right compute, first, there was not the right sensor capabilities to actually, let's say, similar to humans. So that's actually what we are talking about. And then at the same time, there was not the right also compute infrastructure. Right now, everything is based on the brain. So that's how large language models were working until. So you have a GPU, and but if you're looking about physical AI and a dynamic, not static work, basically. So you do need to have something which is more like a reflexive nervous system. And this wasn't in place yet. So this is actually what we're defining right now with the partners out of US, Qualcomm, NVIDIA, and Amazon, like different partners which has the knowledge and at the same time our capabilities to actually define the new state of the art.
Yeah, so talk about Neura Robotics, because what are you guys doing? Explain to the audience so they can understand what's the company's mission, what are you building, what's the value proposition?
Yes, so Neura Robotics does cognitive robots. That means robots which can hear, see, feel, so multimodal, and it can actually react and fully autonomously on different situations. So they learn how to interact with the physical world and how to solve a task. Right? So what are we aiming for? So, because right now we are in a world where we see like there's like an aging population taking place. So it means like there's more people getting retired with skills, physical skills mainly, and less people actually getting trained with new skills, and mostly they're not getting trained with physical skills. So we're getting here a huge gap. So right now in US there's about, let's say, between 6-7 million less human labor by 2030. In Europe there's about 7 to 10 million less human labor, while China has more than 80 million less human labor. So we do need to find a new vessel for know-how and with the capabilities to actually solve physical tasks. And for that there's only one thing like possible, or is it?
Talk about the technology, because that's the holy grail.
Yes.
What you just laid out is what we all want. We want to have robots working with either humans or on their own, with unaided data to adapt to any situation. See, hear, touch. Yeah. What does that technically look like? Is that full stack? Because now you have all kinds of new elements. Touch, dexterity. What am I touching? You got to, like, where's that data coming from? Yes. What if they see something they haven't seen before? So there's all kinds of reasoning challenges, contextual, semantic challenges. So I'm kind of, my mind's blown, so just share with me the full stack.
It's an awesome thing. So, it's also like, I got asked a lot, David, why are you actually building also hardware? I mean, your platform game is awesome. It's much more profitable if you just focus on software and platform, or like an AI. But here's the challenge. There wasn't a hardware platform yet, which has actually the right capabilities of sensing to actually create the right data, to actually feed the brain with the right data to have actually, let's say, some knowledge and also reaction. So this is actually what we are solving right now. And it's also what you saw like in the latest funding round. We didn't focus on the money, like just cash is important, but the most important thing is like the right partners. For what exactly? Again, sensorization, the right capabilities of feel of touch, the eyes, and the hearing basically by audio sensors, like to actually have this multimodal version of sensors, streaming the right data to a brain and nervous system, and this is the other complexity I would like to talk about. It's not enough to have just a brain like we do vision language action models. Vision language action models are good, but not enough for physical AI, where everything is moving and dynamics. So, and here I like to make the example of swimming. You can't learn swimming by just your brain. So it means you can't watch a video for 1 year, 2 years, 5 years and be a swimmer afterwards. It's impossible. The reason for that is you can't learn swimming just with the brain. So you do need to go into the water and train something else. And this is your nervous system. So it means how do your reflexes react on different situations of your breathing, of your muscles, to actually stay above the water. And to make that happen for physical AI, you do need to have a new computer architecture. So this is the other big complexity we are solving right now with partners like NVIDIA, Qualcomm, and others. And then basically the other part is like if you're having like a limited way of knowledge in your brain, like you do need to have something like to distribute this knowledge. You do need to have something where you're actually able to, let's say, to gain more knowledge, or having your training infrastructure is actually the cloud computing itself. So really like building an ecosystem.
You need to have a cohesion. You need cohesive, vertically integrated system, because my touch has to know, my brain's got to know what that's doing. Swimming, golf, sports, anything you do, you got to feel it.
Yes. It's even more that even your brain does not even have to know that what you're, so that's the interesting part. It's like when you're grasping, like for example this here, so and then filling it up with more water, how does it work? It doesn't, like the reaction on your hand, it's not coming out of your brain. So the brain is actually giving you the task and also the way how you do things.
Yeah, and don't overfill it.
Yes.
It's done.
Yes.
Stop.
Yes, exactly. But this reaction comes actually out of your nervous system also. So your shear forces of your fingertips defining the pressure or how much you press on. And this is basically also, and this is required in the physical AI space. If we want to do the same task as humans can do, we do need to be also flexible as humans, and this is the complexity, but also solvable.
The hardware that, I like this approach because I think that it only works this way, because in operating system computer science, you have a lot of subsystems, but the physical hardware is input, could be voice, but keyboard, monitor, and other things, input-output. Your I/O, your input-output, is everything on the machine, the robot. So you're basically building a supercomputer data center that moves and thinks, and it all has to be coordinated through system software, AKA nervous system, brain, touch, vision, hearing. That cannot work well if it's not fully integrated.
Exactly, and not fast enough.
Fast enough, yeah.
So it has to be also fast enough like a nervous system. You have like a millisecond reaction time, while the brain is 2 to 400
Okay,
milliseconds.
so now I'll play the role of a VC, or in your case, private equity. Oh, it'll never work. David, it can't scale. You got too many things in the air. You're spread too thin. You got hardware, you probably heard this before.
I heard a lot.
Okay, I can imagine. See, I'm like, I can predict these things because I've been there. Yeah. But you're taking a deliberate approach, because if you do that successfully, I'm just riffing with you on this, you can then maybe set the hardware standards and maybe outsource some of the heavy lifting on scale. So are you thinking about that scale piece? I see what you're doing, which I love, because you can get to the answer faster.
Yeah.
What's the scale piece?
That's exactly the point. Like, so why we do all these things, like why we do full stack, as just to define it. I mean, our goal is actually first define it, so the brain gets the right information so it can actually react. So that's what we're doing right now. Reaching this standard, our idea is actually to open source the sensor stack, the compute stack, so others can also have.
You're like NVIDIA.
Yeah, and
NVIDIA did
working
this.
with NVIDIA. So for us, it's important that we are partnering with. Like we want to enable. We don't want to just be like solve something for ourselves. We want to enable others, because I think it's a much more comfortable place to be. Why? Because the topics we are still having, they're so big. I mean, and this is, I think, the next claim I would like to do is like, it's not enough to have just a smart device. Because a smart is like having an autonomous car, which is smart. I don't believe this is the solution for everything. I think there should be a layer above the robot, and that's what we call Neuraverse, is the platform. And why is this so important? Because this is the agentic AI tool which orchestrates also everything. So what I mean by that is like, it does not make sense to have a robot walking up the stairs and open the fridge and see there's nothing inside. It makes no sense, right? So the best way would be the robot communicates to a platform above the robot, which can look through the eyes of the fridge and gives you the information before you're actually walking up the stairs. So, and this is the superhuman senses, and this is actually something we are working on right now. It's not enough to have a smart robot, it's actually you having a platform, and this is also the future, in my opinion, the core of our product, is actually a platform where you can actually train the device, you can actually distribute your knowledge on a device where you have your brain account, we call, and then also start trading with the knowledge.
And you could feed it data from things it may not see around the corner.
Yes, exactly.
It's a connected system.
Yes.
All right, so I've seen examples of this, very trivial examples, but you're doing a little bit differently in robotics. But if you look at companies like Amazon Web Services, built from scratch, they had to build their own scale, they built their own machines, Google did the same thing. Facebook, when they had to scale, they essentially built their own data centers, they built their own, even though they did open source, and then donated that IP to the Open Compute Foundation, and then everyone was building. Why did they do that? Because they want more suppliers. That was not their core competency, but they still need to be large scale. You're doing, in a way, a robotics version of that, solve the problem, scale it up to where you can, create a new market category, and then let others participate.
We just don't want to be the bottleneck. We want to enable others, and I think this is the best place to be.
You're not doing a proprietary closed system.
No.
but it has to be closed to work
Yeah.
in that use case.
Yes. So this is actually exactly the point. Like here we are also collaborating like with Amazon, for example, in the cloud compute level, like where we are also using some of the tool chains there, and at the same time also building together the next like needed components for physical AI. So for us it's always important to find out where others already better than us in, and the second is actually where can we make actually a big difference. And in my opinion, one thing the world didn't consider yet is actually that we don't want to have the same thing happen like with OpenAI and Anthropic in the physical world.
Yeah.
And this is a claim which actually my whole company is based on. We don't want to have one brain knowing everything and taking all the information from others and somehow train it. Because I think it's not right, because this is happening right now in the chat world, like with ChatGPT. So basically all the lawyers and all the doctors, whatever, they have a problem in the future. So, but that's not my point. The point is actually the core reason for existence for every physical labor company, like which are doing physical labor work, is actually know-how in the way how they do things, or they're different than others.
Yeah.
So, and if we take all of that into one platform, then we are taking the reason for existence. So that's also why our approach is not taking it, but actually enable them. So give them a brain account so they can train the model themselves, so they have a clear advantage to their competitors and actually solve all the problems which they are experts in with our platform. And then actually using that knowledge and license it to other again, and make a business model out of that. That's
an open source principle.
Exactly.
Well, congratulations, I love this conversation. We're probably going to do it in an hour, but we got to go. Congratulations, love the focus, love the vision and the mission.
Thank you.
And scale is there, great to have you on theCUBE.
Thanks for having me here,
Yes.
so great pleasure, and would love to visit you guys also in
US.
US.
We'll follow up for sure, Palo Alto and New York. Have you back on, love your venture. Again, robotics, this is a whole nother architecture. We're inverting the model, but still open will win. This is the big debate, it's the big discussion. How fast can you push the physical AI robotics era to get the functionality right in a way that's going to help humanity and not close it down? So more conversations coming here in theCUBE. Doing our part to keep up. I'm John Furrier, host of theCUBE. Thanks for watching.
Thanks so much.